everybody. Thanks for coming today. Let's see what we're going to be doing. We're going to be working on quadratic equations here. So I'm sure you guys have seen the depth of what can be asked from quadratic equations. One of the things they love to do is test on identities, which is something we'll be getting into a lot today. Difference of squares being the main identity that I believe they like to test on. So you just got to be prepared to see it and then, of course, be able to use it. So that's what we're going to do a lot of today. We'll do about 30 minutes of questions, and we can do a quick Q&A and then call it. So I'm just getting open what I want to do, guys, first. As you know, this is a chapter that's pretty early on in TTP. It's a pretty important one because quadratics themselves can show up in a lot of cases. Now, one of the interesting things about the new GMAT 2, we get this a lot. You know, somebody recently added in some lessons. For example, we added in the quadratic formula to the course. Now, the reason we did that is because the quadratic formula is something that's now tested on the GMAT. I don't recall it ever being tested previously, but we've definitely seen some official questions from the MBA.com practice exams where you need to use it. So, I mean, honestly, it's an easy thing to memorize, an easy thing to use, so it certainly doesn't hurt. But these are kind of some of the changes that have happened with the newish version of the GMAT. So anyway, first question is up. Give you guys a minute or two, work through this, and then put your answer in the chat box. So I see a lot of good, oh, perfect. Everybody got this right. So the key on this side here is seeing the difference of squares, right? So when you look at the difference of squares, you can easily do the math out here. So you can say, 5 factorial minus 4 factorial, 5 factorial plus 4 factorial, right? And then from there, that's obviously equal to something that we're doing with, you're seeing prime values here. So obviously some sort of breaking into primes is what needs to happen. The 13 is actually a decoy. I don't know if you guys noticed that, but it definitely is. There's nothing very clever going on with the 13. Other than that, you just have to raise it to the 0 power here. So when you do the math out initially with the 5 factorial, 4 factorial, you should probably just have these memorized if you don't, but that's just equivalent to 120 minus 96, And then from there, you do the math in the parentheses. I mean, we don't have to necessarily do it all the way out, but 120 minus 96, 120 plus, or excuse me, not minus 96, minus 24, 120 plus 24, and then all you're doing is you're just doing the prime factorization from there. So what the difference of squares did here is it just made the math easier. What you're going to recognize is there's 0, 13, so that's why you don't have to really bother with the value of 13. And yeah, break down into primes, you add them up, you get 12. Everyone seemed to do that very well, so that was perfect. So let's keep going here. Here's the next thing. All right, take a look at this here. All right, I see a lot of good answers here. Did you guys use difference of squares to solve this? All right, good. So you knew to do 3 to the 4 minus 2 to the 3, 3 to the 4 plus 2 to the 3, and then, of course, 2 to the 6 minus 1, right? And then at that point, all you're really doing from then on is just prime factorization. So there's not a whole, well, not prime factorization. You're doing the math inside of the parentheses here, and then you're seeing what divides in. Obviously, values like 89 and 73 are probably going to divide in. I would never see a random number being the correct answer. So keep that in mind. Like if you thought, oh, 89 is the right answer, then you got to ask yourself, is there something that I just didn't do math-wise, and that's why I'm coming up with that answer. So just be careful of that. When you do it all the way out, yes, 11 is the answer because you end up getting 73 times 89 times 63 times 65. So all of these divide in evenly. All right, next up, let's do, I like this one here. Try this. Okay, so what was the process for everybody here? Did you guys first use difference of squares and then get into unit digit patterns? Yeah, exactly. So you can do 3 to the 15 minus 2 to the 15, right? Then you can do 3 to the 15 plus 2 to the 15 all over 3 to the 15 minus 2 to the 15. And then, right, and this cancels with this. You're left with 3 to the 15 plus 2 to the 15. You can obviously use unit digit patterns. If you notice, there's a 5, there's a 3, there's a 2, there's a 7, there's a 9. The only unit digit you end up with is 9, and that's how you come up with that answer. Any questions about that? All right, cool. Keep going here. All right, this is another good one here. All right, so what was the process you guys took here? Obviously, we're talking about factor by grouping, right? Making sure you guys see that okay. Is that what you guys used, factor by grouping here? All right, cool. And what was your process when you did that? What was the first thing you did? So you pulled out the K on the left. Okay, I agree with that. When you pulled out your K, what did you have after that? Right. So when you pulled out a K, you knew you had K squared minus 2K plus 1, which converts to just K minus 1 all squared, which shouldn't necessarily be any sort of a shock, right? And the reason is because it needs to match what's here. Now, here's a question I have for everybody. Did anybody go ahead and divide out K minus 1 all squared? Was that something anybody did here? All right, good. Because a lot of students make that mistake. So you bring that over, right? And then you pull this out, and then you're left with K plus 11. And then, yes, K is equal to 1 or K is equal to minus 11. Any questions about that from anybody? Just make sure you're not dividing out when you can. As long as you do that correctly, you'll be in good shape. In fact, I can do one more here, similar nature. So take a look at this. All right, try this one here, everybody. Yes, the answer here is B because it's minus 11 plus 1 equals minus 10, exactly. You can't divide both sides by K minus 1 squared because if it's 0, it's going to create an undefined equation. All right, and similar process here. Pull out an x squared plus 2x plus 1. And if you're unsure what the left side is going to be equal to, I mean, honestly, you can just, you know it's going to have to match up with that because you're going to have to use factor by grouping. You also get it memorized, but yeah, you have that, and you pull out the x plus 1, or you bring this over rather, x times x plus 1 squared plus 2x plus 1 equals 0, and then yeah, you pull out the x plus 1 squared again, you're left with x plus 2 times, x plus 2, and then yes, x is either equal to minus 1 or minus 2. Sum that together, you get -3. All right, good. So, I mean, we covered actually a lot of ground today. So I think, yeah, hopefully this was helpful and you can kind of start to see how important difference of squares is. I mean, it is incredibly important. So yeah, you just got to be able to properly execute with factor by grouping with different squares, quadratic equations. We have a ton of it in our course. So I'm sure most of you've seen it. Now, difficulty, I'd say these are medium to high level questions. You can't divide because if it's equal to 0, you're going to cause an undefined equation. And again, we teach that. We have a whole lesson like that in our course. It's a really good lesson. Any other questions just in general about your studying, TTP, anything like that? Any questions at all? The hardest quadratic, I mean, there's a ton of them. I don't know if I could define it. I mean, all the principles can be tough. It just depends on what's being tested within the framework of the problem. Yes, patterns is in number properties, yeah. No, I'm not going to do any more examples. How to accelerate the verbal portion? I mean, you can skim things when you understand them in the chapters themselves, right? And just focus on the practice questions. I think that's a good way to do it. Which parts of prime factorization? I'm not really understanding that question. Any other questions? The answer wasn't 9. The answer was, that's a 5. Yeah, word problems is a tough one. I do tell people to take breaks, move on, and come back. So I'm okay with that. Like if you get through the chapter, but the chapter tests are becoming a grind, yeah, just move on from them. There's nothing wrong with doing that. Yeah, that's okay. You can move on. Come back to them. I mean, if you feel like you have a decent handle on the concepts, it's fine. No, do each chapter test, review, the next chapter test, review, so on and so forth. Any other questions? Yeah, usually they're once a week. Yeah. Any other questions? Yeah, I would have to end in a 5. You just have to get the unit digit pattern of 3 and the unit digit pattern of 2, and then add those together. All right, cool. There's no more questions. Good work today, everybody. Well, we teach that in our. The short answer is yes, I do, for repeating patterns of 4. We teach it in our chapter too. All right, cool. Well, thanks everybody. We'll talk. We will talk probably Thursday of next week, Thursday or Friday of next week. So reach out if you need anything, and good work today.